Thank you, Jay. So the first thing that we're going to look at is how you actually get onto the API. So if you haven't already set up your API access and gotten your application set up, you're going to want to go to the AT&T developer portal. So it's if you use that URL, or you can scan the massive QR code. This will also be available online later if you need to get access to it, or any of these friendly AT&T developer staff members can help you out. The next thing that you need to do is, once you've actually got your API keys and you want to get started authenticating your app to the API so that you can connect your voice to text system, what you're going to want to do is we use the OAuth 2 client credentials grant type to obtain an access token. So if you're not familiar with OAuth 2, there's a variety of different grant types that you use to authenticate either a user or a client with a service, and to make sure that you are who you say you are. And this uses a client ID and a client secret. On the AT&T developer portal, the client ID is going to be called your API key, and then the client secret is called your secret key. After you've gotten your access to your client ID and client secret for getting your access token, you're going to want to make sure that you are prepared for the type of audio that you need to be importing. So what you've got is two different file types, as Jay mentioned earlier, AMR, and the specifics of restrictions is that it be narrowband, 12.2 kilobits per second, and 8 kilohertz sampling. And then WAV files, you can see in the Flex application that's included in the demo, that actually gives you a WAV file, a single channel WAV file with 8 kilohertz sampling. It's fairly easy to actually manipulate WAV files. You can use a variety of different packages to do so. And then there's a couple of restrictions around length. With the voicemail context, they can't be longer than 4 minutes. So you want it to be 4 minutes or less. And any other context that you're using to connect to the AT&T Speech API, it's 1 minute or less. Once you've actually got your API keys, the first thing you're going to do is connect with OAuth. The way that you do this is you're going to put together an HTTP request of a request method post, and you're going to send it to a predefined URL. This is a fairly standard process for OAuth, is submitting it to the OAuth access token URL. You're going to submit it as a URL encoded form, and the body of the request, so the body of the post request, is going to be your client ID, your client secret. It's going to say grant type equals client credentials, and then it's going to have a scope parameter. Now that scope parameter, if you're using just the Speech API, it'll just be speech in all capital letters. But if you're using multiple APIs from AT&T, like maybe the SMS API, or some of the other APIs available on the developer portal now, you may have multiple scopes here. And you would just use a comma separated list for that. And when you get that response back from OAuth, after making that post request, you're going to get back an access token. You also get an expires value and a refresh token that are currently not used, but will likely be used in the future. After that, you're pretty much ready to translate. The only thing you need to do then is submit your audio to AT&T. Now there's two different HTTP request types that you can do this with. You can either, as Jay mentioned, use streaming, or you can use a non-streaming HTTP request. The difference is that a non-streaming HTTP request, you have to have the entire audio file before you make the post. If you have the streaming, you can start sending that audio file as it's being recorded. Ideally, you're going to be using the streaming as often as possible, because that's going to give the best user experience, because you're going to be able to get that translation back fast. But the first thing I want to do is walk through the HTTP request for non-streaming, because that gives a little bit more of the fundamentals so that you can understand the request itself. The request URL is very simple. It's just the one endpoint that you're going to be using, which is the speech-to-text endpoint. You're going to use the first request header is accept, which defines which type of response you're going to get back. We recommend using the application JSON. Right now, there's a couple of other options on the API, but we're recommending the application JSON because it's the easiest to work with, and it's the one that we are for sure going to be continuing with in the long term. Authorization is your OAuth information. This is a standard request header that includes bearer, space, and then your access token. And that's to say who you are. The content type is where you include either audio wave or audio AMR. If you're, just as a recommendation, if you're massaging an audio file around in wave, one of the things that you might discover is that it's actually coming back as content type audio/x-wave. And if you need to, that is equivalent to audio/wave for the purposes of submitting it to AT&T. But you need to make sure that in the request header, it actually is audio/wave, or it will throw back there. The next piece is content length. Now, content length is unique to non-streaming HTTP requests for this purpose. That's the total byte size of the audio file that you've gotten. You can get that by reading the file and just getting the length there. And different platforms will do that in different ways. And then the last piece is X-Speech context, which is a custom URL request header that's going to be used for business search, web search, question and answer, all of the different contexts that Jay mentioned. Now, to submit that audio, you don't want to make it an attachment, you want to make it the actual body of the post. So when you make this HTTP request, the actual body of the HTTP request will be the audio file. The next example here is the exact same thing, but for a streaming example. To do a streaming HTTP request, you need to have access to some sort of streaming library or write your own interface to connect over HTTP and keep it alive. So the big difference here is that in the request header, when speaking to AT&T, you're going to include what's called transfer encoding chunked, which basically just says, hey, I'm going to send you chunks of data over time, and you're going to read that from me. And once I get finished and you see a 0 chunk, we're done. So we suggest, and the recommended size is 512 kilobytes per chunk. So if you look here, the numbers on this example are actually the numbers that you would see in console, which are in hexadecimal. And so the iOS and Android SDKs handle all of this for you. There's not currently any SDKs for the web, but there are some options available coming soon with things like WebRTC and other new device device parameters that you can access over like the iPhone and things like that, where in HTML5 you can access that directly. So now we're going to walk through the example application on the side screens. So if you were here for the Sphero demo earlier, we had a small glitch where hopefully that's taken care of. But one of the things I want to do is we're going to walk through quickly just an example of accessing the audio and getting through the 3 main steps of audio transcription. There's 5 steps in this example app, and the first 3 are dedicated to capturing the audio input. So first we're going to connect the audio. Sorry. Can you turn the mic? Okay. We have feedback, so. Computer History Museum. And so what I did there was I connected the mic. I went in and I set up my flash settings so that it automatically accepted the microphone connection. Normally a little dialog will pop up and the user will have to hit accept to access it. When you click save, it actually saves that audio file, and as I showed earlier, there is actually a folder inside of the example here. In public audio, you actually have the audio file that was just recorded. So that audio file is where you, if you want to go check the parity of your audio file, if you want to see exactly what the computer is hearing, you can go in and check it there. And then we're going to just send this off to AT&T, and we're going to wait a second or so. It's roughly about the same amount of time to, as you record, is how long it takes to transcribe. And I said Computer History Museum, and we got back Computer History Museum. So we're going to walk through the individual pieces of this at this point. So Watson.js is the Node.js wrapper that I wrote that handles a lot of the heavy lifting for Node.js users to interact with the API itself. It's available on GitHub and on NPM right now. And it's going to be consistently maintained for the foreseeable future. So using Watson.js on Node is fairly simple. It's like any other API wrapper that you've used. You just require the client into your app. Then once you've done that, you set your client options. And the client options are equivalent to mostly what's in the request headers when making your OAuth 2 calls to actually connect with the AT&T API. So the client ID and client secret are your API key and your secret key, respectively. And then if you've already gotten an access token from AT&T and stored it in your, for example, stored it in your database or something like that, you can include that when configuring it, or you can get a new one after the fact using one of the built-in methods. Then you enter your scope, which right now Watson.js only supports speech and it only supports the WAV format of file type, but I'm going to be adding AMR soon. The context, in this case, we're just showing you generic. It could be question-answer, it could be U versus EPG. And then it includes the access token URL and API domain, which are optional options. You don't really have to include those because they're already preset. Once you've done that, you instantiate the client, and then you have access to the two main methods of Watson. And this is going to be what, if you write your own API wrapper in any of the other languages, or if you're going to be just using one of the ones we've already built, you're going to have basically two methods that you're going to interact with. You're going to have a get access token method, which allows you to request a new access token or refresh an access token depending on which API wrapper you're using. And the other is the speech-to-text method. And what it does on Node.js is it reads the buffer from an existing file and it pipes that directly to the AT&T Speech API over POST. Then it returns the JSON response directly to whatever callback you give it. So now we're going to walk through this code step by step. So I want to point out some of the frameworks and requirements that we had that we used to build this app. We use Node.js, we use the file system module, so you have to make sure you include that so that you can modify the files. We used Express, which is a really minimal web application framework, similar to like Sinatra on Ruby, things like that. Optimist allows us to do some command line option parsing, so that's what allows you to put the space 2 dashes key equals blank and just override your API key on the fly. HBS is a view engine wrapper for the Express view engine, which allows you to use handlebars, which is a really simple, lightweight template language for writing HTML. And then obviously we're using Watson.js, which is our API wrapper for AT&T. And then on the client side, we've got jQuery, SwiftObject, and Bootstrap. So the first part of this was capturing the audio input. Now this is actually fairly non-trivial on the web. Luckily on the mobile devices, you've got it easy. You've got the SDKs that'll handle almost all of that for you. On the web, it's a little more complicated because you have to, as some of you have found out, you have to deal with Flash incompatibility issues, you have to deal with microphone access. There's a variety of hurdles that you have to overcome. The included Recorder Swift and Recorder.js have a bunch of events that you can hook into when making your own application, and the Recorder is open source if you want to find the package for that and build it yourself, make modifications to it. I'll be able to give you all that information later in the day. Just come see me, and we'll also be posting it up on the GitHub repo as well. The third piece of that is the node upload script. This is a super simple piece that's really not necessary. You could actually pipe it directly from the API call in the Recorder directly to the AT&T API. But in this case, we wanted to show you and give you more of a permanent access to that audio file. So if you wanted to read that audio file and listen to it yourself, or if you wanted to do manipulations on it, you would be able to. And then comes the easy part. You just post it straight to the AT&T API. So in this case, we're just doing a simple post. It's just an HTTP request. to the speech-to-text REST endpoint. And all we're doing is we're using the built-in API method from Watson, the API wrapper, to send public audio, audio.wave, and that file name, you would want to change that to whatever the current file name is. So if you're having a 10,000 user system that's going to be using this, you want to use something like a WIG generator to generate the file name so that you're not going to have collisions of file names. In this case, because it's on your local machine, we just included one static file name. And then you use the actual speech API response. So I want to walk through this speech API response and show you exactly what the response is. So the outer container is the recognition object. And this is just a standard JSON object. The recognition is the body object that wraps everything. The response ID is a unique identifier for that specific API call. So you've made a ton of different API calls, you're handling them all in the background. If you wanted to store this information, that would be a unique identifier for you to use in that case. The NBEST is an array of hypothesis objects. So every possible transcription that the AT&T API, Speech API, thinks this could be. So let's say I say stars and stripes, and it thinks stars and stripes, and then I may have slurred words or something, and it may think I said stars on stripes. So let's say it has both of those. In the future, we'll have multiple NBEST objects. Right now, it should be returning only one, and that will be the best available one. The inside of that object, you've got a variety of different things. The first thing that matters to us is the result text. The result text is the plain text cleaned up version of the text. So it takes out any artifacts, anything that it thinks like, oh, you had a little bit of a long pause there, and there's an ellipsis, something like that. It may pull all of that out and make it clean. This is what you should be using to show the user. So say, hey, this is what we think you said. The next thing is the confidence score. So if you see here in the example on the screen, you've got a 0.75 confidence score. That means that it's 75% confident that this is what you said. In this case, it has a grade of accept, which means that it is confident enough that you should just accept this as what the person said. If it's something that we're not entirely sure of, like let's say one of the words was a 0.1 confidence score, because each of these individual words has their own confidence score. We may say, hey, you need to confirm this with the user. So the grade will actually say confirm. And at that point, you're requested to show that text to the user and say, is this what you said? Or otherwise, ask them to say it again. The next thing is the actual individual words. So there's an array in the words parameter that is just an array of the individual words that matches up with the word scores array that allows you to get the granular confidence scores for individual words. So if you wanted to, say, have a 10-word statement that someone said, and you understood 7 out of those 10 words to 100% confidence, and wanted to then take those 3 words and ask them what those words were, but not ask them to repeat the entire thing, you could do that. The next thing is the language ID. So right now, we support English and Spanish, but the English is in English is in all contexts, and then Spanish is only available right now in the generic context. And the final thing is the raw transcription of audio, which is the hypothesis. So the hypothesis is, this is exactly what the computer thought you said before it tried to clean it up. And next, we're going to have Micheal Fitzpatrick from Verbal come up and talk about a specific implementation that he's done to use the Speech API over phones.